so in this example, we're going to find the area under the curve, and the area of the region that we're interested in is the region that's bounded above by this curve, the tangent inverse of x, bounded below by the x-axis, and then it's bounded on the left and the right by the interval from 0 to 1. Okay, so it's going to look something like this. Oops. Let's go through the origin. Let's put it up here. Okay, so that's the region that we're looking for. Okay, so how do we begin? Well, we need to integrate this, but it looks like we only have one function. So just like before, we're going to use the other function is going to be just the constant function for 1. So we're going to let du, or u rather, be this. So we're going to let u equal the tangent inverse of y, because we can't integrate this the way it is. So we're going to u equals this, and then dv will equal dx. And so if we take the derivative of this, so du, now this is where you have to know your derivatives for inverse trigonometric functions, okay? So the derivative of inverse tangent is 1 over x squared plus 1 dx. And then this is the integral of this gives us v equals x. And so now we're just going to set up our integration by parts now. So this is going to go a to b, right? So we're going from 0 to 1. And so it's going to be so we're doing this, so it's going to be u, right? Okay. There's our u to v equals uv, so it's going to be x times tangent inverse of x minus the integral. Oops, don't forget we're evaluating this from 0 to 1. And then the last integral is v to u. So it's going to be this times this. So we get x over x squared plus 1 dx. Okay, so now look at what we have. So this is fine. This is done. Okay, look what we have here. Now we have something that we can do a u substitution with, right? We've got something in the numerator that looks like the derivative of something in the denominator. Okay, so we can actually use a u substitution, and this is going to give us the form of du over u, which gives us the integral of the natural log, right, of the absolute value of the bottom. Okay, the only thing we have to deal with is the fact that the derivative of this is 2 times x, so we'll have to do 1/2, right? So if we do our u substitution here, and we let u equal x squared plus 1, and du equals 2x dx. And so if we take 1/2 of both sides, oops, okay. Okay, so now we get what? We get x tangent inverse of x, evaluated from 0 to 1. And so this gives us what? The integral. So when x is 0, u is 1. When x is 1, u is 2. And we get 1/2. And we get du over u, right? And so now we're going to get x tangent inverse of x from 0 to 1 minus 1/2. And this is going to become the natural log of u, or the absolute value of u. Evaluated from 1 to 2. And then now we're going to evaluate it at the limits of integration. So we're going to do 1 minus 0. So at 0, this whole thing is going to be 0. Okay, because x is 0, and so we're just going to get 0 here. At 1, this is going to be 1, but what is the tangent inverse of x? So in other words, what the tangent of what angle will give us 1? So the tangent of what angle will give us 1? Well, that's going to be pi over 4, right? It's a 45, 45, 90 triangle. So that's going to be pi over 4. So the answer, so to evaluate this one, is going to give us pi over 4 minus 0, right? And then minus, well, what do we have here? Well, this is going to give us minus 1/2. And this is going to be evaluated from 1 to 2. So the natural log of 2 minus the natural log of 1. Well, what's the natural log of 1? The natural log of 1 is 0. So we get 1/2 the natural log of 2 minus the natural log of the absolute value of 0. Or excuse me, not 0, 1. Which is just 0. And so we get what? This is 0, we get pi over 4 minus 1/2 the natural log of 2. We could drop the absolute value sign because it's just a constant and it's positive. And that's our final answer. So that's the area. Now this would be the exact answer. If I wanted you to put in your calculator, you could get an approximate answer just by putting this in your calculator, but this is the exact answer. And if I asked for the exact answer, this is what you would just use. Okay? And so that's the area bounded by the curve and the x-axis on the interval. That's it. So let's do another example.